What is a Latin square? Some people say it's just a solution to a Sudoku puzzle. I'd wager that it is much more than that. A Latin square is a construct used in experimental design. It is essentially an array with the same number of columns and rows, as well as having the same number of different symbols. These symbols can only appear once in each row, once in each column. A useful tool for dealing with Latin squares is orthogonal array representation. Basically, it is a way of describing Latin squares in which each entry in said Latin square is written as R, C, S, where R is the row, C is the column, and S is the symbol. Now, let's see how a Latin square is useful in the world of experimental design. Latin square design in its purest form is the application of Latin squares to organize data in an experiment where you have two outside sources of variation. These sources of variation also have to have the same number of variables as each other. These two extraneous variables make up the rows and columns of our Latin square, and the symbols will be representing tests we perform on these two variables. Large Latin squares don't normally appear in Latin square design. This is because the number of tests used in the experiment isn't very large. According to J.D. Hart, a statistician from Texas A&M, the formula for determining how many different Latin squares we can derive for however many tests or treatments we're using in our experiment is n factorial times n minus 1 factorial. This formula is obtained from recording legitimate Latin squares from our experiment, then permuting the rows and columns randomly. It is very easy to analyze the data garnered from said experiment. However, some things to note about Latin square design are squares that are smaller than 4 by 4 are impractical because they will have a very small number of degrees of freedom. Also, the effect of each test must be about the same across both rows and columns. It is up to the researcher to choose whether or not to use Latin square design, as it is situationally better for different experiments. Let's see an example applying Latin square design to engineering. Let's say you are an industrial engineer testing machines to see if these machines differ in any way in their ability to manufacture a certain part. There are 4 machines that need to be tested. There are 2 external sources of variation in this experiment, being different operators working on the machine at different time periods during the workday. The operators would represent 4 columns, and the 4 time slots would represent the rows in the Latin square. We randomly assign the 4 machines to 16 cells of our Latin square, but the only restriction is that each machine can only be used once by each operator and once in each time slot. Using the data collected from different Latin squares we derive from our experiment, we can see which combination of operators and time slots results in the most efficient use for our 4 machines, and then optimize our production schedule based on this data. I hope this example cleared up some of the intricacies of Latin square design for you.